So in this video, I'm going to continue looking at rationalizing surds, and this time in particular, we're going to be focusing on conjugate surds. So the conjugate refers to an identical expression where the sign between the two terms is the opposite to the sign of the original expression. So if you're kind of trying to visualize what exactly that means, for example, let's take 4x plus 3. The conjugate of that expression is 4x minus 3. So notice that the sign in between the two terms is the opposite of the other. So we know now that when surds are multiplied together, the result of this is a rational number. So remember that a surd is considered to be an irrational number. So what happens is when we multiply two surds together, they become rational. So based on this, we can rationalize denominators containing a sum or a difference of surds. In order to rationalize a denominator that contains a sum or difference of surds, we multiply the numerator and denominator by the conjugate of the denominator. So again, if that seems like a bit of a mouthful, feel free to pause the video now and process it yourself. I will be going through the worked examples, which will help to put this theory into practice, and it'll make a lot more sense once you're working through the examples. So conjugate surds, for example, can include root 6 plus 11 and root 6 minus 11, or if you're looking for something a lot more general, root a minus b, the conjugate of that would be root a plus b. So if we take a look at the first example, I've got 1 divided by 4 minus root 3. So if I'm going to rewrite this to rationalize it, what I'm going to do is write the conjugate of the denominator. So the conjugate of 4 minus root 3 is going to be 4 plus root 3. So now rewriting this to rationalize this, I'm going to have 1 divided by 4 minus root 3 multiplied by 4 plus root 3 divided by 4 plus root 3. Again, remember, we're not trying to change the question. If we look at 4 plus root 3 divided by 4 plus root 3, what I'm actually doing is I'm just multiplying the original question by 1. So now what we're going to do is apply the distributive law to the numerator and the difference of two squares to the denominator. So I'm just going to write that here and make sure you take a note of it as well. So we're applying and then I said we're applying the difference of two squares identity. Sorry, that was my bad. I wrote denominator up here. I meant to write numerator. And then difference of two squares identity to the denominator. So when I'm talking about the difference of two squares, I'm referring to the a plus b times a minus b rule, which basically gives us a squared minus b squared. And if you're kind of a bit hazy on that, pause the video now, have a go at expanding a plus b times a minus b, and you'll find that your final answer will be a squared minus b squared. So returning now to the original question, I'm going to apply the distributive law to the numerator, so that'll give me 4 plus root 3. And now applying the difference of two squares identity to the denominator, I'm actually going to rewrite this as 4 squared minus root 3 all squared. So now simplifying this, I'm going to have 4 plus root 3 divided by 16 minus 9. And I'm just going to write, I've got a bit more space here. So 4 plus root 3. Now simplifying that, that's going to be divided by 13. So again, what you can see here is we have rationalized this surd here, but what we've done now is we've actually, instead of multiplying it by the denominator itself, we've multiplied the original question or expression by its conjugate. So you can see that the denominator has gone from being an irrational number to a rational one. So now if we move to the next example here, I've written root 6 plus 3 root 2, all divided by 3 plus root 3. Again, the conjugate here is going to be 3 minus root 3. So I'm going to rewrite this as root 6 plus 3 root 2 divided by 3 plus root 3, and then multiply that by basically the opposite. So 3 minus root 3 divided by 3 minus root 3. Again, we're not changing the question, we're just sort of multiplying it by 1, but I'm going to rewrite it as its conjugate. So here it's going to be a little bit more time consuming with this particular question because there are so many more elements to it. If you want to pause the video and have a go at doing it on your own, feel free to. Otherwise, keep watching and we'll work through the answers together. So again, here I'm going to apply the distributive law to my numerator. So I'm just going to write it out for myself, otherwise I'll make a mistake. Minus root 3. So now root 6 times by, I drew my arrow a little bit too far over. So that'll be 3 root 6 minus root 18 plus 9 root 2 minus 3 root 6. And all of that divided by 9 minus 3. So now looking here where I can simplify things, I've got repeat there, so they basically become 0. I can simplify root 18 more, so I can go root 9 times root 2 plus 9 root 2 all on 6. So that'll become minus 3 root 2 plus 9 root 2 on 6. And now again, simplifying my numerator a little bit more, I've got 6 root 2 divided by 6, and now I can divide the 6's, so my final answer will be root 2. So again, hopefully you can see here that what we're doing is we're rationalizing surds, this time using its conjugate, and just remember that we are rationalizing the denominator by using the sum or difference of surds principle. If you think back to when we did algebra, for example, applying the distributive law is really important here, and being able to identify the difference of two squares identity. So hopefully you're feeling a little bit more confident about using, rationalizing surds after watching these. And again, practice is the way to go. Make sure you're practicing your surds, simplifying them, and hopefully with a lot more practice, you get much more confident at it.